Hello everyone. This video on introducing ERPs is presented by Ridge Tech Team. First, let us see some basic concepts of ERPs features. ERPs is short for Ethernet Ring Protection Switching Protocol. Actually, parts of its function is similar to STP, and it is used for loop prevention too. The biggest difference between ERPs and STP is the convergence time. The convergence time of STP is in second level. However, the convergence time of ERPs is in millisecond level. In this slide, we can see the specific differences between ERPs, STP, RSTP, and MSTP. According to the Excel, we can see the convergence time of ERPs is the shortest, and it can realize loop prevention and load balancing too. This video is divided into 4 parts. First one is application scenarios. The next one is handling mechanism. Next one is load balancing. And the last one is configurations. Now let's begin at the first one. In this slide, we can see there is a single ring in it. It means our ERPs can be applied in single ring. And what is single ring? We can know there is only one real ring in this topology, so we call it a single ring. We can see there are 3 lines in this slide. One is RPL owner, another one is RPL port, and the last one is RPL link. So what are RPL owner, RPL port, and RPL link? RPL is short for ring protection link, and RPL owner is responsible for blocking traffic over the RPL so that no loops can be formed in the Ethernet ring, and there can be only one RPL owner in a ring. RPL port is the blocking port of RPL owner, and we need to specify and configure it manually. RPL link is the link which contains RPL port, and we call it RPL link. In this slide, we can see there is a tangent ring in it. And why we call this topology tangent ring? Because there is a shared load in this topology. This load belongs to the left ring and the right ring at the same time. In this slide, we can see there is an intersection ring in it. It is not hard to find that there are many shared links in this topology, and we call the shared link virtual link. We call this ring intersection ring. One thing needed to be mentioned is that there is and can be only one major ring in an intersection ring, and all of the rest are subring. Okay, let's move to our second part, handling mechanism. We divide this part into 2 small parts, link failure and link recovery. In the next part, we will introduce the working mechanism when the topology is fine and the link is wrong. First, when the topology is working fine, we should manually define one node to be the RPL owner, and then the RPL owner will block its RPL port and send out an R, no request, and RB, RPL owner blocked package. When the other nodes receive this package, they could know the ring is working fine. Then, if there is one node in the topology is blocked, it will trigger the hold-off timer. At this time, let us see what a hold-off timer is. The hold-off timer is used to filter out intermittent link faults. For example, the quality of some cables may be not very well. Sometimes it's fine, sometimes it's faultily wrong. This will cause network flapping. At this time, if the ERPS reacts immediately, it will cause some unnecessary problems. So the hold off time is used for this scenario, and its default time interval is 0. The range is 0 to 10 seconds. Okay, let's go back to the slide. When the timer is exhausted, the adjacent nodes will block the fault link and send the SF single-family packet to other nodes to report the fault. When the RPL owner receives this packet, it will open RPL port, and the data will be transmitted through these 3 nodes. And this topology is the latest topology. Okay, we have finished the explanation of device failure. Now, when the device recovers, the labeling nodes of fault device will send an NR message to RPL owner. At this time, guard timer will start. Now, we need to introduce what the guard timer is and what it is used for. The guard timer is used to block the latent outdated message from causing unnecessary state changes. For example, as we know, when the device failure happens, the RPL owner will open its RPL port, and after that, the RPL owner will send NR RB packet again. So the guard timer is used for reducing this outdated message, and its default time is 500 milliseconds. The range is from 10 to 2000 milliseconds. Okay, when the RPL owner received the NR packet, the WTR timer will start. At this time, we need to introduce what the WTR timer is and what it is used for. WTR is short for wait to restore. It is used to verify the NR packet is not intermittent. For example, I have used this example just now. If the cable is unstable, sometimes good, sometimes bad, it will cause network flapping. The WTR timer is used for preventing this circumstance, and its default timer interval is 5 minutes. The range is from 1 to 12 minutes. Okay, when the WTR timer is exhausted, the owner node blocks the RPL link and sends NR RB message. Once receiving the NR RB message, the node will open the previously blocked port, and the link will recover. Okay, till now, we have finished the learning of single ring working mechanism. And actually, the tangent ring has the same working mechanism like a single ring. Only we need to divide it into 2 single rings, and the configuration is the same. Like the slide before, not only the tangent ring has the same working mechanism as the single ring, but also the intersection ring has the same working mechanism. And the only difference is that we need to divide the intersection ring into several single rings, and the configurations are the same too. Okay, in this slide, there is one thing I need to mention. As we can see, there is an intersection ring in this picture. When the virtual link is broken, the RPL owner of the major ring will open its RPL port, and the subring will do nothing. That's because the virtual link can transmit data for the subring, but it belongs to the major ring actually. So that's why only the RPL owner of major ring will open RPL port. Okay, let's move to the next part, load balancing. First, let's see the working principle of load balancing. One physical ring is configured with multiple Ethernet rings, and different Ethernet rings send different VLAN traffic to realize load balancing of traffic. In the other words, there is only one physical ring, but we can configure many logical rings, and the different logical rings will transmit different dates. Just like showing in this slide, between these 4 switches we can create 2 logical rings. One is the blue and the other one is the orange. We realize this function by using different instances and configuring different RPL loads. Well, this part is our last part, configuration. First, let's know how to configure in a single ring. We need to enter the privileged mode and create an RAPS VLAN. I need to mention here, if the VLAN is configured for ERPS VLAN, it cannot be used for transmitting dates. It can only be used by ERPS. Then we need to configure the port mode to be trunk, because if we configure the port mode to be access, it can only permit only one VLAN pass through. Then add the specific port into ERPS and configure RPL owner manually. Then enable ERPS ring function and enable ERPS globally. And we can see here, the rest switches configurations are similar to the switch 1. We only need to pay attention to the read tips on this slide. After the configuration, we can use show ERPS to check whether our configuration is right or not. As we can see in the picture I mentioned, the status is enabled, and for RPL owner, one of its ports is blocking to prevent the loop. For intersection ring, it is similar to single ring. Only we need to pay attention to is the switch 1 and the switch 2 joint 2 rings. So we need to configure 2 rings on them. Well, let's move to node balancing. First, as we can see in this slide, we need to divide some VLANs in one instance and divide some VLANs in the other instance. So there are 2 instances and we need to create 2 ERPS rings. And in different instances, we need to specify different loads to be RPL owner. Okay, that is all we'd like to share about ERPS. Any question you can contact us via our official Skype. We will serve you wholeheartedly.